What if the bright green glow streaking across our sky isn't just the breath of a comet, but a message from another star? Tonight we face a paradox. The James Webb Space Telescope sees chemistry we know: carbon dioxide, cyanide, fine grains of water ice. Yet the way 3I Atlas behaves defies our expectations. It moves faster than anything we've built. Its path brushes past multiple planets as if by design, and its size dwarfs anything we've ever seen from beyond our solar system. Is this simply the most exotic comet ever recorded, or something far more deliberate? As scientists weigh natural explanations against bold speculation, one truth emerges. The universe is speaking in a language we're only just learning to hear. And the story begins right now. Welcome, my friends, to Velocity of Comets. Tonight, I want you to set aside the familiar world for a moment. Imagine yourself not in your living room, not in your city, but standing on the rim of the desert, beneath an ocean of stars. The silence is complete.
Good morning, everyone.
Broken only by the ticking of your
a
telescope as it tracks across the
astronomical
sky.
event.
And then, suddenly, there it is, a faint emerald glow, small but undeniable, carving its way across the black canvas above you. That glow is 3I Atlas, only the third confirmed interstellar object humanity has ever detected, and already one of the most mysterious. At first glance, it resembles a comet, with a tail of dust and gas trailing behind it. But the numbers pouring in from observatories around the world tell us something stranger. This visitor is moving at more than 130,000 miles per hour. Fast enough to travel from New York to Los Angeles in just 1 minute. Fast enough to make Voyager 1, our farthest and fastest spacecraft, look like it's standing still. Even the Sun, with its colossal gravity, cannot capture it. The orbit is hyperbolic, not elliptical. That means it did not come from within our solar system. It came from the deep, dark between the stars. NASA confirmed the discovery quickly, and within hours the world's most powerful instruments were turned toward it. The Hubble Space Telescope snapped images of a diffuse coma, the hazy atmosphere of dust and gas that surrounds its solid core. The James Webb Space Telescope, with its golden mirrors and unrivaled infrared eyes, recorded the spectral fingerprints of its chemistry: carbon dioxide venting strongly, water ice in unexpectedly fine grains, and molecules like cyanide and nickel that surprised even veteran astronomers. On the ground, the Very Large Telescope in Chile picked up matching signals, confirming that this object is chemically active long before water should have started to flow. That alone is extraordinary. Comets from our own solar system tend to behave in predictable ways. First carbon monoxide or carbon dioxide release, later water vapor as they move closer to the Sun. But 3I Atlas seems to be skipping some of those steps, glowing green in part because of molecules like dicarbon and cyanide, and brightening earlier than expected. The universe has handed us a puzzle, and with every observation, it grows more intriguing. And here's where the tension rises. To most scientists, this is the thrill of discovery, an object that forces us to rewrite models, refine theories, and admit that we've only just begun to understand what interstellar comets look like.
Is the dramatic difference between
but in the public imagination, the story quickly took on a different tone. Some wondered if this glow, this tail, was not natural sublimation at all, but something else. An exhaust plume, the kind of controlled thrust a spacecraft might produce. The trajectory, too, raised eyebrows. Instead of sweeping randomly through the solar system, it seemed to brush past Mars, then approach Earth, then curve toward Venus and even Jupiter, as though following a carefully chosen path. Was this a coincidence, or the trace of something planned? NASA and ESA were quick to clarify. The data support a natural explanation. The unusual chemistry fits what you would expect if 3I Atlas formed in a different kind of star system, where conditions favored carbon dioxide over water ice. The trajectory, while eye-catching, does not bring the comet particularly close to any planet. Its so-called approach to Earth, for example, is still 167 million miles away, nearly twice the distance between Earth and the Sun. From a human perspective, that is no rendezvous at all. From a cosmic perspective, it is nothing more than geometry. But as a storyteller, I have to acknowledge what makes people lean in. It's the possibility, the what if. What if this isn't just another comet? What if it isn't random? What if it is something else entirely? A messenger, a probe, a scout. The evidence so far points firmly to natural origins, but the questions it raises pull us deeper into wonder. And wonder, not fear, is where discovery begins. Standing in front of Webb's shimmering images, I can't help but think about how fragile this object must be. It has traveled for thousands, maybe millions of years through the void between stars, battered by cosmic rays, frozen in silence. And yet it arrives here,
the Rosetta
still
probe
intact,
provided unprecedented
still glowing,
views of Comet 67P.
still carrying the chemistry
its distinctive
of its
shape
birthplace.
and active.
That chemistry is not alien technology, but it is alien nature. Every molecule escaping from its surface is a clue to how planets and stars form in distant regions of the galaxy. It's not an engine, it's a time capsule. And in its fragile plume, we are reading the story of another world. So where does this leave us? At the threshold of a great mystery, one where every answer raises another question. Why is the chemistry so skewed toward carbon dioxide? What does its green glow tell us about the building blocks of planets in other systems? How many of these interstellar wanderers pass by without us ever noticing? And perhaps most haunting of all, what if some of them are not natural at all? That's the hook, my friends. The universe has delivered us a messenger from beyond, and in the next part of our journey, we will step deeper into the analysis, examining the competing hypotheses, the bold speculations,
Oh my God.
and the careful science that separates imagination from reality. Because in this story, both sides matter. The imagination keeps us asking. The science keeps us grounded. Together, they keep us human. But before we go further, I want to welcome you once again to this journey. This is Comet Velocity, where we explore the cosmos not as cold observers, but as companions. If you're new here, consider joining us by subscribing, because the more of us who look up together, the richer the night sky becomes. Out there, in the silence between stars, the greatest discoveries are waiting. And here, together, we'll be ready to meet them. iAtlas is not just a distant glow anymore. It's a laboratory in motion, a mystery unraveling in real time. And tonight, we dive into the analysis, the debates, the hard questions. The James Webb Space Telescope, with its nispective instrument, caught the light scattered by 3I Atlas in August. In its spectral lines, astronomers saw fingerprints of carbon dioxide, cyanide, nickel, and fine water ice grains, all streaming into space as the sun warmed the comet's surface. At first glance, this looked like normal cometary chemistry, but the balance was odd. CO2 appeared stronger than expected,
was the
activating at
first
distances
interstellar
where most
object to
comets
pass
stay
through our
quiet.
solar system.
Meanwhile, the water signal was faint, delayed, almost hesitant. What did this mean? Was 3I Atlas revealing an alien chemistry from another star's nursery? Or simply teaching us that our models of comet activity are still incomplete? Scientists put forward several hypotheses. The first, and most conservative, was that this comet simply carried a richer CO2 inventory than the ones born in our solar system. That would make sense if it had formed beyond the carbon dioxide snowline in a distant protoplanetary disk, where CO2 froze solid while water remained vapor.
A comet!
A second idea
Wow,
suggested the
it's so
surface contained
bright.
ultra-fine ice grains, so delicate that they sublimated into gas sooner, changing the activity profile. And a third pointed to thermal physics. CO2 turns to vapor at lower temperatures than H2O, so it would naturally appear first, even more strongly as the comet approached the Sun. None of these explanations require alien propulsion. They require only sunlight, frozen ices, and time. Still, a bolder camp raised an eyebrow. They argued that this wasn't just outgassing, it was exhaust. They noted the comet's hyperbolic trajectory, sweeping close to Mars, Earth, Venus, and Jupiter in sequence, almost like a flight plan.
The odds of such a path arising by chance, they claimed, were vanishingly small. Was this really coincidence, or was it evidence of guidance? Here is where the debate sharpens. NASA and ESA scientists countered that celestial mechanics can produce perfect-looking flybys without any intention behind them. Orbits, especially hyperbolic ones, often align in ways that seem uncanny to human eyes. And those close passes, they sound dramatic, but in reality, they are measured in tens of millions of miles. The closest approach to Earth, for example, is about 167 million miles, nearly twice the distance between us and the Sun. That's far too distant to suggest surveillance. In other words, the flight path looks unusual only because interstellar visitors are rare. Rarity is not the same as design, but the strangeness doesn't end there. Astronomers compared 3I Atlas to its predecessors, Oumuamua in 2017 and 2I Borisov in 2019. Oumuamua baffled us with its unexplained acceleration and unusual shape. Borisov looked far more like a standard comet, comforting in its familiarity. 3I Atlas sits in the middle ground, active and comet-like, yet still odd enough to stretch our understanding. That tension, the line between natural but rare and unnatural but deliberate, is what fuels the conversation today. And then, the numbers. At 130,000 miles per hour, 3I Atlas races faster than anything humans have ever built. Compare it to Voyager 1, humanity's farthest traveler, cruising at about 38,000 miles per hour. The difference is staggering. To accelerate something this large to such speeds naturally would likely require gravitational encounters with giant stars or black holes. But would such an object survive intact across thousands of light years? That improbability is why some wonder if propulsion could be at play. And yet, our physics tells us another story. Yes, rare gravitational events can impart extreme velocities. And yes, fragile objects can survive. Low probability is not impossibility. So where does this leave us, with competing hypotheses on the table? The natural camp, supported by the majority of the data, explains the chemistry, the timing, and the trajectory through known processes. The speculative camp imagines alien craft, deliberate reconnaissance, a mission older than our civilization itself. Both camps agree on one thing. 3I Atlas is unlike anything we've studied before, and it is forcing us to update our models of how comets behave when they come from the great interstellar dark. And this, I think, is where the real wonder lies. Even if every strange signal has a natural explanation, those explanations expand the boundaries of what's possible. They remind us that nature is more inventive than we often give it credit for. The glow we see may
No
not be
propulsion
exhaust,
detected.
but it is a message, written in chemistry, about worlds we cannot see and suns we will never reach. Stay with me, because in part 3 we will reach the climax of this story. We'll explore what these revelations mean not just for science, but for humanity, our future, our curiosity, and our place in a galaxy that suddenly feels a little smaller and a lot more alive. Imagine for a moment that you're standing under the night sky. looking up at a comet that shouldn't even be here. Its greenish glow flickers faintly against the stars, like a lantern carried across an endless ocean. Now pause and let that settle. This light is not from our sun, not from our planets, but from something born under a different star, carrying with it the chemistry of a distant world. That realization alone is astonishing enough to stop the breath in your chest. Let's gather what we know. 3I Atlas has released gases, carbon dioxide, cyanide, nickel, and water ice grains, that match processes we've seen in comets, but with quirks that stretch our models. The balance of activity is unusual, the timing unexpected, the hue strangely vivid. To some, that strangeness whispers of propulsion and design. But to scientists, it sings of physics and chemistry playing out in new ways. No spectrum so far shows engineered exhaust. No trajectory demands an alien pilot. Instead, what we have is an object that both confirms and expands the language of comets. It doesn't break natural law. It teaches us how wide that law can reach. And here's the reveal. The most astonishing truth is not that 3I Atlas might be artificial, but that nature itself is capable of such grandeur. It has crossed the abyss between stars intact, carrying fragile ices that survived thousands, maybe millions of years of exposure to interstellar cold. That means interstellar space is not empty. It is a highway for building blocks, a conveyor belt of chemistry, scattering seeds of life's ingredients across the galaxy. Every molecule we study in this comet, water, carbon, complex organics, connects directly to the oldest question humanity has ever asked.
Natural comet hypothesis.
Or is life woven into the very fabric of the cosmos? Think about the timing, too. We are alive in the first era when humanity has telescopes sharp enough to see these travelers. Hubble gave us our first glimpse. Webb dissected its light. Ground-based giants traced its chemistry. ESA is preparing Comet Interceptor, a spacecraft that will one day sit waiting for the next interstellar visitor.
This model
SpaceX and
predicts
other
the
launch
gravitational
providers are
influence
lowering the
of celestial
barrier to
bodies
rapid
on orbital
response
paths.
missions. For the first time in history, we can imagine intercepting, not just observing, a wanderer like 3I Atlas. Our children may live in a world where interstellar dust is collected and studied in laboratories on Earth. And yet, beyond the science, there is the philosophy. If comets can cross between stars, then maybe life's seeds can too. Perhaps the galaxy is not a silent void, but a garden of possibilities, where fragments like 3I Atlas are the messengers.
They tell us that worlds are connected in ways we have only begun to grasp. They remind us that we are not just an isolated island. We are part of a galactic ecosystem of dust, gas, and frozen archives. Whether or not intelligent life has touched this object, it is still a form of contact, a handshake between solar systems, passed hand to hand through the medium of time. So what does this mean for us? It means we must be ready. Ready with instruments, ready with missions, ready with open minds. The more we watch, the more we'll find. And the more we find, the more we'll realize that we are not just observers of the cosmos. We are participants. Atlas is not here to frighten us. It is here to remind us that we are part of something vaster than our imaginations can contain. In the end, this is not a story of fear. It's a story of wonder. A story of how a small world on the edge of the galaxy finally noticed the travelers passing by. And now that we've noticed, we cannot go back. The next time the sky delivers a stranger, we will be waiting, not with rumors, but with
Interstellar
readiness.
time capsule.
Because the universe is not silent. It speaks in comets, in spectra, in fleeting lights that cross our sky. And if we are wise, we will listen.
When the first whispers about 3I/Atlas spread, the headlines rushed toward the dramatic. Propulsion exhaust, alien craft, reconnaissance probe. But as the data settled in, a different story took shape. Webb, Hubble, and the VLT all saw chemistry that fits with the natural behavior of comets, though with quirks that stretch our models. Stronger than expected carbon dioxide, faint water vapor, cyanide and nickel glowing in the coma. Each line of evidence points to something natural but uncommon. This doesn't diminish the mystery, it deepens it. Nature, after all, doesn't need imagination to surprise us. The astonishing truth is not that we've uncovered alien engines, but that fragile ice and dust from a distant star system have survived a voyage across the galaxy to reach us. 3I/Atlas is proof that star systems are not isolated. They exchange material, share chemistry, and perhaps even scatter the seeds of life. What feels like a rare coincidence is actually a reminder that the galaxy is alive with motion, and that Earth is not alone in receiving visitors from the deep. To me, this discovery is both humbling and inspiring. It humbles us because it shows how little we know. Our models bend with every new interstellar guest. And it inspires because it reminds us that every observation matters. Each telescope trained on 3I/Atlas, each spectrum recorded, is humanity leaning closer to the universe and asking, what else is out there? The lesson is simple. Wonder doesn't demand certainty.
And here
It
we
asks
have a
us to
live
stay
look
curious,
at the comet.
to resist easy answers, and to marvel at the fact that we are alive at a time when we can watch the cosmos deliver its secrets in real time. So now I turn to you. Do you believe 3I/Atlas is simply nature's masterpiece? Or could there be more waiting beneath its glow? Share your thoughts in the comments, and if you want to keep exploring the universe together, subscribe. Because this journey is only beginning, and the next messenger is already on its way.